Okay, what we're gonna, and you'll need a calculator today. Okay, page 7 in your packet, and grab your calculator out. Some of this we will need a calculator for. Okay, today we're gonna look at, we learned about different types of data displays yesterday. Today we're gonna look at how to get data off of a data display. Okay, how to read them, how to tell what it's talking about. Okay, so we'll look at histograms. We're gonna look at circle graphs, bar graphs, line graphs, and how to read those. So the first one is a histogram. So just a reminder that, remember, a histogram from yesterday is a special type of bar graph where all the bars are right next to each other and we have intervals. Okay, this particular histogram talks about how many waves were caught at a beach. Okay, meaning somebody's out surfing and they're catching waves, right? They're trying to get up on a wave. It says which interval contains the fewest data values. Okay, so we have our different intervals here. We have 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49. Which interval contains the fewest data values, has the least amount of data in it? Which interval from that graph? Okay. 0 to 9, right? Why would it be 0 to 9? There's nothing there. Yeah. So 0 to 9 has the fewest data values. Okay, then how many surfers were at the beach? If we want to figure out how many surfers are at the beach, we need to know how many people are in each bar. How many people caught between 10 and 19 waves? I would say that's about 15 people. How many people caught between 20 and 29 waves? 24. Between 30 and 39, I would say is about 23. And 40 to 49, I'd say is about 5. So how many surfers were at the beach? What do we have to do with those numbers? Tyler, add them all up. So 15, 24, 23, and 5, what do you get? Caleb? 67. There were 67 surfers at the beach. According to this histogram, is it possible that a surfer did not catch any waves that day? Is that possible? Is it possible that they did not catch any, Brooklyn?
No.
No, why not?
Because there's nothing.
Right. Because if they didn't catch any waves, there'd be a bar here, right? In the 0 to 9. But there's not. Okay, so let me ask you this question before I go to the next one. Can you tell me how many people caught 10 waves? By looking at this histogram, can you tell me how many people caught exactly 10 waves? What do you think? Do you think you can tell? No, why not? Brooklyn, what do you think?
Because 10 to 19.
Yeah. So I can tell that there's 15 people that caught between 10 and 19 waves, but I don't know how many of those people caught exactly 10. So that's kind of the biggest problem with the histogram. We can't tell exact numbers. We know they might have all gotten 19. I don't know. There might have been 110 and 14 people who got 12 waves. Or they could have all been spread out in that interval. Okay, so would you conclude that this was a good or a bad surfing day? What do you think? Based on the data that's given there, is it a good or a bad day? Kayla?
Good.
Why do you think it's good?
More people were able to get like a lot more people were able to get like 30 or 39 or something.
Right. Well, and everybody caught at least 10, right? So I would say that's a pretty good day. Nobody had 0 to 9, so everybody was catching waves. Everybody caught at least 10 or more. I'm guessing that's a pretty good surfing day. Okay. Questions on how to read a histogram? What if I just asked you how many people caught 30 to 49 waves? What would you say? 30 to 49. How many people caught 30 to 49 waves, Tyler? 28. I'd have to add these two bars together. Okay, what if I said how many people caught 39 to 49 waves? 39 to 49. And what would you say? How come nobody's answering? Can you tell? Why not? Why can't we tell how many people would get 39 to 49? Caleb.
Not exact estimate.
Right. Because 39 is here in this column. I don't know how many of those 23 people got 39 waves. If I would have said 40 to 49, you can tell me that. Okay, that's 5. So just be careful with the numbers that they're asking for. Okay, let's look at the next one. Oops. The next one shows us a bar graph. Okay, this bar graph is about the ages of billionaires. Okay, so there are age 30 all the way up to age 99. Okay, I wish I was a billionaire that was between the age of 30 to 39, but unfortunately I'm not. Okay, so we've got some people that are pretty young billionaires, all the way up to people that are a little bit older. Would it make sense that there are more people that are older as billionaires? I think so, right? They probably had to get a job and work a little bit for their money first. They didn't just inherit it. These people might have just inherited it. I don't know. Maybe they worked hard too. Okay. So it says how many people ages 70 or older had a net worth of at least 4.5 billion? Age 70 or older. How many people would there be? Caleb. 65. You're adding 36, 26, and 3. So there are 65 people who are just billionaires. There are 4.5 billionaires. Okay. What's the approximate range in the ages of the billionaires shown in the histogram? What does range mean? What does range mean? Uh-oh. You guys, we did this a couple days ago. What does range mean? Caleb?
I'm just gonna say it's like somewhat like how far from
Kind of. Tyler?
If you take the high number and subtract from the low number.
Okay, the highest number minus the lowest number. So, what's possibly the highest age on this graph? Maya? 99. Do we know for sure that there's somebody 99? No. And that's why we're saying the approximate range. Okay, so the highest number is 99. What's the lowest? 30. So we subtract them. The approximate range is 69 years. Okay. Letter C. How many people ages 50 to 69 had a net worth of at least 4.5 billion? 50 to 69. How many would that be? Tyler? 77. You're adding these two columns together. Okay. Can you tell me how many people age 30? Can you give me that information? No. Can you tell me how many people age 30 to 39? What if I said 30 to 38? No. Okay. Because we don't know. These 8 people might all be 39 years old. We don't know. Okay. Questions there. All right. The next type of graph is a circle graph. So yesterday we said circle graphs kind of divided into parts. It's part of a whole. We're often talking about percents. Okay, so the entire circle contains 100% of the data. So, if we look at this circle graph, slide 5 on your notes. In 1 year, people in the US purchased approximately 16.6 million bicycles. Okay? The circle graph shows the types of bicycles purchased. So we have mountain bikes, youth bikes, comfort bikes, that's my kind of bike, the bike that has the big seat so you don't get a sore butt. That's why I hate riding bikes, because you finish and the next day you're like, man, what did I do? My butt hurts, right? A hybrid, I'm not really sure what kind of bike that is. And other would be like, you know, the bikes where you have like the recumbent bikes where you sit on them and then pedal with your feet out here, those types of things, okay? So how many of the bicycles purchased were hybrid bikes? Kind of like a mountain bike / speed bike, whatever. Okay, what percent of the bikes were mountain bikes or hybrid bikes? Caleb? 9. So we know 9% of all the bikes were hybrid. Ultimately, that means we need to do a math problem and find 9% of 16.6 million. Do you remember how to do percents? Ooh, now I'm making you think. Anybody remember how to do percents? Remember the percent proportion? Remember this type of thing?
Yeah.
Where we put the percent over 100, 9 over 100. Where should I put the 16.6? On the bottom, right? Because it's of. That's the total. And we solve this. Okay, this is where you need your calculator. Solve the problem. What do you get? Tyler, what'd you get?
1.49.
So is it just 1.494 bikes? 1.494 what? Not percent. Million, right? 1.494 million bikes were hybrid bikes. That's a lot. Okay, but there was a lot of bikes. Okay, letter B. How many of the 16.6 million bikes purchased were not comfort bikes? What percent of the bikes were comfort bikes? 21. So if 21% of the bikes were comfort bikes, what percent was not comfort? Zachary. 79%. So we really need to find 79% of the 16.6 million. Okay, so we do the same thing. We set up our proportion. We want 79 over 100. The 16.6 goes on the bottom. And we solve that. What do you get? Go ahead, Tyler. 13.114 million of the bikes were not comfort bikes. Now, if I would have got, like, let's say 18.5 million, would that be a reasonable answer? Would you know your answer's wrong if you got 18.5 million? How do you know what's wrong? Yeah.
It's bigger than the 16.
Right. Your number can't be over the total amount, right? There was only 16.6 million bikes sold. So make sure you're thinking about if your answer is reasonable. If you get a number bigger than 16.6, you did something wrong. Questions on that? Okay, now sometimes on circle graphs they can ask you really easy questions. Like, what percent of the bikes were youth and mountain bikes? If I said, what percent of the bikes are youth or mountain bikes, you would say what? Caleb. 63%. If I said how many bikes, then you need to do the math. Okay? If I said percent, you can just add the percents together. Questions on circle graphs and how to find those percents. Alright, the next type is a double bar graph. Okay, remember bar graphs display data in categories. So flip the page in your packet. Okay, here we have a bar graph that shows the number of tickets sold in 1 week by the boys and girls in grade 7. Okay, so they were selling tickets for something. Who knows, maybe it's like a musical or whatever it is. How many girls are in 7th grade? How are we going to figure out how many girls are in 7th grade?
Oh,
Brooklyn.
there's a key at this.
There's a key over here. So the girls are on your paper, the white columns. Up here, it's the yellow ones. Okay? So what do we do with all the white or yellow bars? What do we have to do? Add them all up. So right here, I have 4 girls, another 4 girls, 9 girls, 8, 3, and 6. How many girls are in 7th grade? Kimberly? 34. Okay, there are 34 girls when I just add up the girl columns. How many students sold 20 tickets? How many students sold 20 tickets? What would you say, Nina? Not just 3 girls sold 20 tickets, but what about the boys? So remember, there are 5 boys, so how many students? Mm-hmm. So then it would be what? 8. So that's where this gets tricky, right? Just reading the problem. So if I asked for girls, I would have only wanted 3. If I asked for boys only, I would have wanted 5. But because I said students, I want them together. What if I said how many students sold at least 20 tickets? Then what? How many students sold at least 20 tickets? What does that mean? Right.
It means from 0 to 20.
Not 0 to 20, but at least 20 means 20 or more. So if I say at least 20, then I'm looking at all of these columns. So I would do 5 plus 3 plus 2 plus 6, so it would be 16 people. Okay? So again, one of those, be really careful what they're asking. All right, next one is a line graph. Okay, actually this one's a double line graph. It's used to show how 2 sets of data change over time. Remember, we talked about that yesterday. So use the graph to estimate the number of CDs and DVDs sold in 2003. Okay, looking at this graph, I am guessing that these dots, the dot and the diamond, that represents the year 1998. The year 2000, the year 2002, and the year 2004. So where would the year 2003 be? Right. So I'm going to draw a line right here, going straight up. That line would represent the year 2003. Everybody agree with that? Okay. So now if I want to know how many CDs and DVDs were sold in 2003, I need to figure out how much is that and how much is that and put them together. So how many DVDs do you think were sold in 2003? About, because we don't need to be exact, approximately. I'll go like this dot. Does that help? So how much would that be? Caleb?
I guess it would be 3,600.
Maybe. So DVD about 3,600, somewhere in there. It's gonna be close. Okay. And CDs, if I draw this line, try that again. I'm gonna draw this line over here. What would that be? CDs would be about what, Tyler? Maybe 5,300, 5,200, 5,300 we'll go with. So if I want to know the total of both, I just need to add them together. So 0, 0, 9, about 8,900. Okay. I don't know exactly, but it's got to be close to that. Questions there? Okay, last one. This one gets a little bit wordy. Okay, here's the cost of a homecoming dance. I should have made it the cost of prom, since prom is this weekend. Okay. So if the cost of the dance increased at the same rate between 2003 and 2004 as it did between 2004 and 2005, what was the cost of the dance in 2003? Is that confusing? A little bit. Okay. So tell me, by looking at this graph, how much did the cost of the dance go up between 2004 and 2005? It went up how much? I would say in 2004 it was $2,900, and in 2005 it's $3,000. So how much did the cost of the dance go up from 2004 to 2005? Caleb?
About
$100. Everybody agree? It increased $100. So if that increase was the same the year before, how much would the dance cost in 2003? From here to here, it only went up $100. So if we had to go backwards, where would it be? Down 100, which would mean what was the cost of the dance in 2003? Caleb? $2,800. Okay, because it would have went down the same amount. All right, if the cost of the dance continues to increase at the same rate as it did between 2008 and 2009, what will the cost of the dance be in 2012? Okay, so let's look at between 2008 and 2009. From here to here. In 2008, the dance cost $3,400. In 2009, it cost $3,700. How much did it increase? What was the increase? Caleb? $300, right? Everybody agree? It went up $300. So in 2009, it was $3,700. It's going to continue to increase at the same rate. So what's it going to be in 2010? It went up $300. What's it going to be in 2010? If it's going to go up another $300. Caleb?
about like
4,000. Does that answer our problem yet? No, we want 2012, so we need to keep going. So what would it be in 2011? It's going to keep increasing at the same rate. Tyler? 4,300. So 2012 will be, Caleb?
4,600.
So in 2012, it would be $4,600. Because it's going to continue at that same rate. Okay, questions there? All right.